Hey folks, Quill18 here, and welcome to another Unity 3D tutorial where we're looking at how to make a 2D tile map in our world. So we've got most of the generation down. This episode we're going to look at two things. One, we're going to give this just a little bit of wibble wobble and height just to give the basic idea of where it is. It might be something we look into more in depth later on. The height itself is very easy to do. Basically, we just have to give it a little bit of a Y factor, and in this particular case, I'm literally just going to use a random range from I don't know, let's say negative 2f to positive 2f. So just a little bit of wibble wobble. And let's see what that looks like. Now this is just going to fluctuate basically just like mindless noise. But it is not really tall enough. Oh, I forgot because our scale is bigger than it was before. So let's go ahead and make it from -1 to 1. That might be a little bit more notable. Oh, I forget that I don't have to hit play anymore. I can just hit regenerate. And there we go. So you can see we've got a warped world. Now, obviously, the random function is not... where can I go? Space. There we go. The random function is not what we'd want to use to actually generate this kind of noise. We want to tie this into our actual sort of level data. For example, if we were using the actual Earth map, then what we'd also want to do is want to get some sort of Earth elevation map, probably an exaggerated one, because in practice, like at this scale, even the tallest mountain would be an inconsequential little lump on the surface. Yeah, you can even see part of it from the bottom, just because you can still see the elevated sides. So you'd want to get that in there, and then you'd want to, there's different techniques that you can use to read it. But what we're going to look at later on is actually how to sort of create this kind of information procedurally ourselves, and that means we'll be able to generate our own height data at that point. But one could easily imagine that what you could have here is some sort of lookup table for the height at a particular point, which would actually be relatively correct. The thing is, this step here is building the visual mesh, but we'd actually want to have our actual map data in another class, another data structure that's not really a Unity object, because it's just sort of pure data being worked on. So we'll get a series of generators there, and that will give us some sort of data. And so for each one of these tiles, we could look that up. And same thing, instead of applying an actual finished texture to the product, we could actually just generate the texture by the same process. So we'll look at some of those techniques a little bit later. But here what I want to do is I want to go back to the idea of we want to be able to mouse over and choose a tile, right? We kind of want to go back to the way things were at the beginning. Now, what we could do is, again, we could create a series of maybe invisible cubes over the surface, and then you can do an on mouse over on those. But I've already discussed why that's not terribly efficient to create so many objects in Unity. You know, in our hierarchy here, you just start to overflow the system and becomes a little bit crazy. But there's no reason that we can't do a very similar sort of thing just using the current map. And what we're going to do is, well, we're going to do just that. So we're not running. Good. No. All right. And one of the things that's interesting, actually, with the height data the way it is now, if I kind of zoom in and then select it, I guess it does turn kind of ugly. But if I hit regenerate, you can see that the height definitely changes every single time I click this button. So everything really is getting recreated from scratch. There's also no reason, if you want to do a sort of wave effect, that you actually have to recreate the entire thing. You could have another function that simply goes through, you can pull all the vertices out of the mesh, go through them each, just change the little Y coordinate here, and then feed the vertices back into the mesh. You wouldn't have to recreate absolutely everything. But you can see, even though like this is quite a few triangles, right? It runs fast. The regeneration is fast. The fill rate, again, let me go to render set. No, we want to go into quality settings, and here I'll turn on the highest quality, but then I'll turn off VSync, and the camera is pointing in a stupid place. Oh yeah, because of where I had things before. So we've got a camera here. Now if I hit play and load up the stats, there we go. Now that's a frame rate, like well over 1,000 frames per second, although that's without any lights. So let's go and create a couple of point lights. They're pointless point lights. We need a range of, say, 100. There we go. So we'll have one over here, and we'll duplicate it and put one over here. Actually, let's take both of these and change the range to 250. There, not bad. So now we've got 2 lights in the world, and I hit play, and we're still getting stupendous speed. Like, it's not even, this is not even a concern, because it's the one object, even though it's, you know, it doesn't even have that many triangles. But we could take the same thing, and, I mean, I could crank this, right? I can go over here, and let's add some zeros. So now we're going to have an object that is going to be, well, let's start with 50,000 triangles and see how that does. Hit play. Actually, I don't need to hit play. I just need to, yeah, regenerate. So our map is, it's stretched out, right? Because our proportions are all wrong. But our frame rate is still very, very good. Triangles. Oh, right. It's 50,000 squares, 50,000 tiles, but it's 100,000 triangles. Chugging along just fine. Let's go for something utterly ridiculous. Hope this doesn't crash my recording. Oh, that's right. Unity has a limit that any single mesh can't have more than 65,000 vertices. I forgot about that. And that is just a Unity sort of memory data structure limit. It's not really anything with the actual efficiency of the video card. But that's fine. I mean, you don't need, if you ever needed more than that, you could always split your mesh into 2 for some reason. But that's never going to be an issue. So runs very quickly. I am going to actually turn on the VSync once again. Here, every blank. And that'll cap me to about 60 FPS, plus or minus various things. Okay. So, because more is not necessarily better. More just makes your CPU melt for no reason. So, right, so I want the mouse over functionality back. That's the actual point of this particular thing. So, our map, I mean, we have the TileMap function here. And I could add it to the script, right? I could just add the on update, but that's a little silly. In fact, this TileMap script should maybe be called TileMap Builder or something. We're going to create a new component. And add a new component. We're going to call this TileMap Mouse. It's the TileMap Mouse script. So it's going to create the dummy one, and then we can double click on this. And this is going to be responsible for actually showing us what tile that we're mousing over. And for that, we basically we're going to do it with the update technique, which is fine. We're going to use the similar technique that we had before. Did I get rid of the... Oh, right, I had tile mouse over. I can just quickly copy and paste from that because we're basically going to use the same code here. So let me close that, paste it over here. All right, so now we're going to do the same thing. We're going to shoot a ray at our tile map. We're going to see if we collide the tile map. And right now, what this will just do is it will colorify things. It will colorify our map. Let's just do this. And then we'll reset it to color.green, even though this is so, yeah, this is just a demo. All right, so we're going to move this over this way. We're going to hit play. Everything should be, oh, really? Oh, because this is returning false. That's right. So every frame, it's going to check to see if our mouse is over the map. If it's not, it goes green. If it is, it's going to go red. Why isn't it not working? Well, because I forgot something. We're doing a raycast against a collider. In fact, do we even get an error? No, we don't even get an error. We're doing a raycast against our collider, but our map doesn't actually have a collider. Or rather, it does. That's why we're not getting an error. We do have a mesh collider, but it doesn't actually have a mesh assigned to it. So it can't really do very good collision testing. So we're going to go back into our tile map creation. We're going to go down to the bottom. We've even captured our mesh collider here. We really don't need the renderer. The renderer is we're going to need later when we assign our custom textures and materials and stuff. But so our mesh collider, we're going to have to give it it's actually a shared mesh. Really? Is it? Huh. I guess it is. Oh, right, that makes sense. Because it doesn't actually want to have its own mesh in memory. It wants to point to another existing mesh. That's what's going on there. Oh, I do have to recreate this, though. So regenerate. So right now our mesh collider has no mesh. Regenerate. Now it's not named, but it should work. There we are. Boom. Alright, so the mouse over itself works, but obviously this is not the sort of behavior we want. Whoa, that is psychedelic. We don't want this color change, for one, and we don't want to highlight the whole thing. I mean, yeah, it's nice and all that we know that we're hitting the map anywhere, but really what we want is we want to know where we're hitting it, and that's where the hit info comes in. So hit info dot and point. Hit info.point tells us exactly what coordinates we were struck at. Now, these are going to be in world coordinates. So let's do it. Debug.log on our hit info point. And let's watch the log. So we're going to hit play. So now, there we are. There's our coordinates. So if I go over here to the top left corner, it's going to be, so the first number is the x, so 0 through 500, which makes sense because we're 100 tiles with a size of 5. And at the top is the furthest z, which is 250, which makes sense, 50 times 5. And the bottom will be 0. So this is our 0, 0 corner. And this is our 500, 250-ish corner. So our coordinates are great, except if I take the tile map here, and I'm still in play mode, so this won't necessarily persist, and I move it somewhere over here. Well, now when I mouse over this corner over here, which was my 500, 250, it's giving me different numbers. And the reason is that this is the collision point in world space, not relative to my map. So we want to convert it to our local space. And one of the easiest ways to do it is just to subtract one to the other. Is there, there's the local to world matrix. World to local matrix. There we go. So there's a couple of things we can do. And actually this is probably better. So if I do transform.position minus that, and again, actually let's go ahead and move it in this view. Transform.position minus that, this will give me, yeah, I have them the wrong way around. Or were they already negative? I don't think so. I think it is the wrong way around. I always screw that stuff up when I'm subtracting vectors. There we go. So 250 or 500, 250 up here. So everything is now once again working exactly the way that it should, even though we've moved the map around. It doesn't matter. If I move it here, then I'll see that this is the 0, 0, 0 corner. And indeed, it works. So that's one. But there's still a problem with if I rotate things around. So if I take this guy and I give him a rotation, it will not give me the coordinates that I want. Because again, it's giving me the world coordinates, and yeah, it's subtracting the position, but that is definitely not right. So the best thing to do is probably to do a multiplication with the world transformation matrix. So we're going to take the hit point, and we're going to multiply it by the world to local matrix of our transformation. Is the other way around? Probably, yes, because it's the same thing with quaternions. Matrix multiplied by the position, and now that's not right. Fancy math. All right, so it's right here. I have to be honest with you. I'm just getting this wrong. I have to double check it. Let's, in this particular case, let's just ignore it. Pretend we don't need this. If you need it for your game, you can look it up then. This will work fine. Our world is at the 0, 0, 0 point, so we're going to be okay to continue as is. So we've got the hit point, but what we want to do is convert this to a tile. Because obviously we're getting floating point numbers. That's pretty darn easy to do, because all we have to do is, well, kind of convert these to integers. and that will work fine, right? So we can go something like in x is equal to hit info.point.x, and we can cast it to an integer. What we could use mathf.floor to int, I guess, is probably a better way to do it. Same thing with the z coordinates, and then we can just debug.log tile x z. There. So if I were precise enough, I could get exactly to the endpoint. It should go, yeah, this is the endpoint, 499, 299, or 249, because the bottom, oh, and you can just barely see it. I was going to say it's off the screen, but yeah, I think I can get to the 00 point down there somehow. Actually, if I do this, then I could conceivably go and hunt for the right pixel, but that doesn't sound like a lot of fun. Okay, so we've got that, and it is reporting the correct tile number, but we actually, kind of want to show that. Oh wait, no, it's not presenting the correct tile number. The reason is that it's not taking into account the tile size, because we don't have 500 by 250 tiles, we have 100 by 50. So we actually have to divide it by our tile size, which actually belongs on this other script, which we are going to capture at the beginning. We're going to say, so first of all, require component type of tile map. We want to make sure there's a tile map in general, and then we're going to grab tile map, void start, and we're just going to hang on to that, equals, and get component tile map. I suppose that in C# nomenclature or best practices, you would do something like this to indicate that this is a private member variable. And then, so we can take this and divide it by tilemap.tilesize. And this should properly, at this point, report numbers. Yeah, we can do that. Because this is a float, well, let's throw that in there and then do the round down to an int. So now we've got the 0, 0, and over here we've got, should be 99, 49. Perfect. That's exactly what we want. Okay, so now we've reported the correct tile number, but obviously we want to visually display it. How do we do that? Well, it's going to depend entirely on the game, right? Some games don't indicate when you're mousing over a tile. They just, report something. So at this point, you could, throw up a tooltip, or maybe you've got a status line down below, or maybe it's just, again, you've got a character selected. So when you click somewhere else, then that's when, and you can do that over here. So we've got the on update, and this can cache, we could keep track of something like current vector2 current tile chord or something, right? So when we do here, we can go current tile chord dot x equals x, current tile chord. Well, this is a vector. You know what? Let's just make it a vector 3. Dot z equals z. Else whatever, and then if input dot get mouse button down, if we've clicked down on the right mouse button, which is our move command, and selected unit not equals null, if it's that kind of game, then we can do something like selected unit, not unity. Not that it matters because I'm about to get rid of this. Selected unit dot move to chord, and then you go current tile chord dot x, current tile chord dot z. Right? You could do something like this, and that works perfectly fine. In our example, I was going to do the same sort of highlighting we had before. So what I'm going to do is I'm going to create a cube. This is the easiest way to do it. Yeah, sure. All right, we'll create a cube. I'm going to set it to a 5 by 5 by 5 size. Why can't I actually see the cube? on this screen. Is it too low? No. Oh, there it is. It's just very tiny relative to everything else. Yeah, I forgot that like our map is ginormous here. Yeah, because I guess in a game with a map this size, like if this were Civilization, for example, you wouldn't be seeing the whole map like this. That's just ludicrous. You would be kind of more or less zoomed in quite a bit closer. I mean, you're talking about something like this, right? Oh, I know I'm moving around all crazy like. So then our cube, that is the map. The cube moves to somewhere over Florida. There we are. So now, again, the mouse over function works just fine. And what I would do is, because we can make the cube like a sort of glowy, transparent something or other. Oh, I don't have all my shaders in here. That's too bad. Selection cube. Yeah, because we could use a cool. I don't know. We'll use a transparent shader. I guess I should put my lights back in because it's really dark in here. Transparent diffuse. We will add that to our cube, and we will make it green, halfway transparent. And let's go and add directional light. There, much better, much less gloomy. And so now everything should still continue to work just fine. But we can move the cube. We can say in our tile map, our map script, we can say public transform selection cube, or selection graphic. There's all kinds of different ways you can do it. It doesn't have to be in game. It could be pointing to a prefab. It could be destroyed or recreated depending on what you're doing. But this, there you go. Selection cube is here. And so we've got our coordinates there, and so all we want to do is move the selection cube. Transform.position is equal to, and then we just feed it these coordinates. I mean, technically you could feed it this, although we don't want this. We want more this. We want it to lock to these tiles, so I actually quite like doing it this way. So we can just tell it, actually, just lock it to these tile coordinates. Oh no, we need to multiply it by 5, I think. Times 5f. I think we can multiply a vector by a scalar. Why is the cube? Oh, did I scale it in play mode? That's almost certainly what happened. I think my round down error. I think my round downness is wrong. Let's go to the edge of the map. And on the, whoops, I did not want to close that. I want to get rid of the height thing, just to make it clear what I'm doing. I mean, there's almost certainly several bugs in here. This is a proof of a concept, right? Here we go, the height. So we're going to set this to a 0. We're going to flatten the map out. Let that compile, regenerate. So now we've got a nice flat map. So now if I get to the edge here. Oh, derp, I know what's going on. So it's that age-old problem where the Unity... Oh, that's what happened. I scaled the box collider. Okay, that's pretty typical of what I do. The Unity primitives, their origin is in the center, but everything else about my sort of setup here, the origin is, there we go, the pivot point. The pivot point you can see is in the bottom left corner here. So all of my squares start from there, and what's happening is the center of this cube is actually on the bottom left corner of a tile. So it's kind of offset incorrectly. And the best way to fix that is to, well, to generate maybe a cube in Blender where the pivot point is in the bottom left corner of the cube. But I'm quite a fan of just creating an empty object. Stick the cube inside of that. So, and then offset, oh yeah, we gotta do this. So the game object is going to be at the 0, 0, 0 point here. The cube, we're just going to offset it inside of the game object by half so that it's nicely centered this way. And also we can look at it from the side here. And you can see we also have to lift it by half of the height, which is 0.5 in this case. And now the cube is nicely situated here. And, whoops, I do not want to be light mapping, go away. By the way, some people asked in some previous videos how to get the light mapping window. It's in here. I usually just keep it docked in my inspector, but it's just in the window menu, light mapping. Derp, 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 derp. Get rid of the train tag, there we go. I want to call this my tile selection indicator, because I like wordy things. And then I stick that in here, my selection cube field. So now when I hit play, there we are. So now I can buzz around inside of this square. Everything looks good, and it is correctly highlighting. And it's not sticking out past that. It's because we're looking at a slight angle. It is correctly highlighting to show me which tile I'm currently on top of. And then yeah, I can click and do stuff. Right? I have nothing mapped to the click. Else, hide selection cube. Of course, you can have modes in your game. This map you might have, or this tile map mouse, like this whole mouse handling function. It's very common to have, you know, just create an empty game object and call this like mouse manager, and it's responsible for doing all the mouse interactions. It might have a series of scripts, and they're going to be aware of what mode you're in. You know, are you in highlighting mode? Are you in movement mode? Different things like that. And yeah, again, if input dot get mouse button down 0, which is the left click, debug.log click. Alright, so you would do stuff there of some kind, and it's going to be entirely dependent on what kind of game you're playing. Oh, yeah, the click is happening, but it's just because this runs every frame, and this debug.log adds noise every single frame. We were losing the actual click command. Click, 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 click. There we are. So, that brings us to the end of this particular session. It's a long little run. I'm going to bundle all of this code up and put it down in the comments down below. There'll be a link to where you can download the code for this program and everything else. Basically, the NASA map is public domain, I believe, so I'll leave that in there as well. If you have any questions, as always, please don't hesitate to ask. When I pick this back up again, we will look at some procedural generation techniques, and we will take advantage of some of the code that we've got made today to display what we procedurally generate. But that's going to be procedural generation code is less of a Unity question. In fact, the code we're going to write for that is going to be sort of pure C#, and then our TileMap program is going to use that to generate the actual map and the actual texture as well. So we'll also look at generating images and textures kind of on the fly, and the sort of things you can do with that, even in the free version of Unity. Some things you need to be able to render the texture in the paid version, which I think this is like at the end of a trial run of one from the Ludum Dare. I've got a few days left to this trial, but there's still, you can still generate your own 2D textures from scratch in the free version of Unity, and we will look at doing that. I'm not sure when those tutorials will go up, but I definitely want to do that. So see you next time, folks. Bye-bye.